here we go. Exponents, division, you know how we do it. Yesterday we did multiplication. When we multiplied the same base, we added the exponents. So what would you imagine if we're going to divide? Hopefully you said subtract at home. Okay, so if we were to stretch these out, as I've said in the past, x squared would be x times x over x to the first, and you can cancel out an x for an x, so you're left with x to the first, which is x. Same thing here, if we stretch this out, it'd be y over y times y. Cancel out a y for a y. You're left with a y in the denominator. You got to put a place filler in the numerator. Over yonder, I see we can cancel out a y, no problem. And then 6 and 9 have a 3 in common. 3 goes into 6 twice, 3 goes into 9 3 times. So we have 2x over 3. All right, I see 4 goes into 16, 4 times. Let's see, a times b over 4 times b. And we can cancel out b for b. We got ab over 4. All right, so you might be able to see it up there, but when you are dividing and it's the same base, you subtract the exponents, which you could stretch it out just like we did in the warm-up there and still get to the final answer. But if you can just remember we're subtracting exponents, it'll be so much easier for you. And then negative exponents, we can't have negative exponents in our final answer. So the way we're going to fix the negative exponents is you put them on the other side of a fraction, and then you make it positive. You'll see what I mean here in a minute. So simplify 3 to the 8th over 3 to the 5th. So they're the same base. So we're just going to subtract the exponents. 8 minus 5 is 3. So we have 3 to the 3rd power. That's it. That's all they want us to do. Now, if they said, like, what's that actual answer? Simplify it all the way. 3 times 3 is 9 times 3 is 27. Which that's honestly what you would get if you actually computed 3 to the 8th, got some very huge number, divided it by 3 to the 5th, which is another huge number, it would still come out to 27. So here these are both, the base of both of these is a, so we can subtract the exponents because we're dividing. 4 minus 2 is 2. So again, if you can't remember that rule, which you should, you can kind of use your brain. A to the 4th is a times a times a times a. A squared is a times a. And then you can cancel out an a for an a, and an a for an a, and you're left with a times a, or a squared that way. All right, so 10 to the 7th over 10 to the 4th, subtract the exponents. 7 minus 4 is 3. So 10 to the 3rd, or 1,000, right? If it's 10 to the something power, it just means that many zeros, essentially. X to the 25th over x to the 18th. Now this is where it's actually very beneficial to know the rule of exponents, because you don't want to write 25 x's in the numerator and 18 x's in the denominator. So if we just subtract 25 minus 18, we're left with 7, x to the 7. Now if there are regular numbers, coefficients in front, you treat those just like you would a regular fraction. This is just a shortcut we can do when we're dividing with the same base and they have exponents on it. So here the 12 divided by 3 is just 4. 4 over 1, right? But you don't need to write the over 1. We have m to the 5th over m, which is m to the 1st. So if you subtract those exponents, 5 minus 1 is 4. So we have 4 m to the 4th over 1. You don't need to write it over 1. Great. If you have anything to the 0 power, jot this down. Anything to the 0 power equals 1. And that's true. And I can show you why that is if you'd like. You do? Want to see? Okay. So let's go with like 3s. 3 to the 3rd, 3 to the 2nd. Oops, that's a 2. 3 to the 2nd, 3 to the 1st, 3 to the 0th. And let's actually keep going. 3 to the negative first, 3 to the negative second. So 3 to the first power is just 3. 3 to the second power is 9. 3 to the third power is 27. So as you go to the left, on the way I wrote it, you're multiplying by 3. If you were to go backwards, 27 to 9, you're dividing by 3. 9 to 3, you're dividing by 3. So if we kept that going, 3 divided by 3 would give you 1. And then even dipping into the negative exponents, if we did 1 divided by 3, it would be the fraction 1 over 3. So 3 to the negative first power, to make it positive, you put it under a 1, and then it becomes 1 over 3 to the first power. And if you kept that going, 3 to the negative second power, you put it under a 1, and you make it positive. And 3 to the second power is 9. So that's where we're going with the negative exponents eventually. Let's get at these 0 exponents. Anything to the 0 power is equal to 1. So here, if we subtract these exponents, negative 8 to the 2 minus 2, we get negative 8 to the 0, which is 1. Or if you look at it right away, you have the same thing in the numerator and denominator, just like if it was the fraction 10 over 10, the 10s would cancel out and you're left with 1. Same thing here. You have the same thing in the numerator and denominator. So here, I see the b to the third over the b to the third. Those can just cancel each other out, right? Same thing in the numerator and denominator, cancel it. So we're left with the fraction 6 over 18, which would reduce to 1/3. 43 to the 0 power. What's anything to the 0 power? 1. Technically, they say everything except for 0, because 0 to the 0 power is undefined. Don't worry about that. I'm not trying to fool you with little things like that. I do want to say this, though. There is a difference between, if we had, kind of like with the exponents, these will give you 2 different answers. If it's in parentheses and it's to the 0 power, it's going to come out to 1. If it's not in parentheses, we're talking negative numbers. If it's negative, not in parentheses, it's like saying the opposite of 1. So negative 1. If it's in parentheses to the 0 power, positive. If it's in parentheses, or it's not in parentheses and it's negative to the 0 power, negative 1. Just be careful of that. All right, on B, we're subtracting the exponents. 5, it'll be 2 minus 1. For x, it'll be 6 minus 6. 2 minus 1 is 1, so we have 5 to the first power. We'll have x to the 0 power. Anything to the 0 power is just 1, so you can just get rid of it. Because 1 times anything is just that number. That's our identity property of multiplying by 1. So then we're left with 5 to the first power, which is 5. All right. X to the 5th over x to the 5th. Same thing in the numerator and denominator. Cancel it out. Because 5 minus 5 would be 0, and x to the 0 power is 1, so it just vanishes. So we are left with y to the 6th over y to the 3rd. If you subtract 6 minus 3, you get 3. And then on D, this is something I see mistaken all the time. They will see 5x to the 0 power, and they will just write 1, because they're like, anything to the 0 power is 1. That's true, but this one's different, because the 5 actually has its own exponent. It's 5 to the first times x to the 0 power. So the x to the 0 power can disappear, but you're left with 5 to the first, which is just 5. So be careful on those. Okay. Now we're getting into those negative exponents. So you will see that to make a negative exponent positive, you drop it under a 1. If we'll get there. We'll get to more complicated ones, and I'll tell you what I was about to say in a minute. So here, if we were to subtract the exponents, 6 minus 8 is negative 2. To make that positive exponent, which we have to for our final answer, you drop it under a 1, so 1 over 5 to the second power. And then what's 5 times 5? 25. So it would be 1 over 25. That is one way you can do it. Here's the way old Mr. Plant, with his simple little brain, tries to think of it. Are there more in the numerator or denominator? Which one's bigger, the 6 or the 8? Obviously, the 8 is bigger. So wherever there are more is where they will end up. So if there are more in the denominator, they're going to end up in the denominator. And then you can just do 8 minus 6 is 2. So you have 1 over 5 in the second, which will give you 1 over 25. That's the way I prefer to do it. Figure out where there are more of them, and that's where they'll end up. So here, are there more m's up top with 2 or on the bottom with 5? Obviously, more on the bottom. So they're going to end up in the denominator. 5 minus 2 is 3. So we just end up with m to the third in the denominator. Up top, we got to put a place filler for the fraction in the numerator. Or if you want, the book's way is 2 minus 5 is negative 3. You make that negative by, you make it positive by putting it under a 1, and then you're done. Hey, either way gets you there. I'm good either way. On A, are there more 4s up top or on the bottom? On the bottom. There's 7 on the bottom, 5 up top. 7 minus 5 is 2. So there are 2 more 4s in the denominator. So 1 over 4 squared, which is 1 over 16. More a's in the numerator or denominator? Denominator. How many more? 6 minus 4 is 2. So 1 over a squared. Are there more in the numerator or denominator? Denominator. 12 minus 8 is 4. And then we got the big boy numbers there. We got to mess with those. 3 over 9. 3 goes into 3 once. 3 goes into 9 3 times. So we'd have 3y to the 4th in the denominator. Throw a numerator up there. Last type of example, write this without a fraction bar. I'm not a huge fan of these kind of problems. I would just rather say, like, simplify everything. But here's what they want you to do. They're saying x, subtract the exponents, 2 minus 3. And then the y, subtract the exponents, 3 minus 1. So 2 minus 3 for the x would be negative 1. 3 minus 1 for the y's would be 2. This is the answer they want. And the reason I don't like that is because, yeah, it's answering their question, but typically I'm going to want you to simplify it completely, which means you can't have negative exponents. So if we were to simplify this, the y to the second has a positive exponent, so it doesn't need to move at all. The x to the negative first, that's a problem. So the way you fix it is you just drop the x to the negative first underneath. So really a simplified answer would say y to the second over x to the first. That's the way I'd prefer you just do it. But we'll answer their question the way they want it for now. Okay, you got it, textbook, you got it. B to the third over b to the ninth, we're just writing it without a fraction bar. So we're subtracting 3 minus 9, which is negative 6. That is the answer they want. If we said simplify it, it would be 1 over e to the 6th. Subtracting exponents for the m, we have 3 minus 6. For the n, we have 2 minus 8. 3 minus 6 is negative 3. 2 minus 8 is negative 6. This is the answer that they want. If it said simplify, then it would be 1 over n to the third and n to the 6th. One more. Subtract the exponents. For the x, we have 1 minus 5. For the y, we have 5 minus 3. 1 minus 5 is negative 4. 5 minus 3 is 2. That was almost too fun. I don't know how I do it, guys. I don't know.